Right, so question 29 here, they give us the following reaction. We've got phosphorus pentachloride is a gas, and it is at equilibrium with phosphorus trichloride, which is also a gas, and chlorine gas. And it tells us this is endothermic. So if this is endothermic, then heat can be thought of as a reactant. So I want to have heat as a reactant, and I want to write it as a reactant. Correct, Raf. So what happens in the partial pressure? What happens to the partial pressure of the phosphorus pentachloride if the temperature of the system is raised? Right. So if I raise the temperature of the system, that's like adding more heat to the system. In the system, heat is a reactant. So Le Chatelier's principle says if I add more of something to a system at equilibrium, the equilibrium is going to move in a way to use what was added. So by adding more heat, I'm going to push this equilibrium to the right, and that's going to decrease the partial pressure of the phosphorus pentachloride because I'm pushing that equilibrium to the right. I'm pushing it farther forward to make more products in this equilibrium. Question 30 is related to that. It's also Le Chatelier's principle question. And we've got this potassium sulfate, hydrogen sulfate, sulfite. It's a solid, and that reacts to form potassium, which is also a solid, and water, which is a gas, and sulfur dioxide, which is also a gas. So this is at equilibrium. What happens to the partial pressure of water if more of the potassium hydrogen sulfite is added? So we add more of this. And to answer this question, right, we're adding more of a solid. Solids don't show up in our equilibrium concentrations. They don't show up in our equilibrium expressions. They don't show up in our equilibrium calculations. So I can add as much solid as I want to this. It's not going to change the equilibrium of this reaction. So it'll have no impact on the equilibrium. So this would do nothing to the equilibrium position of this reaction.